Yes, thank you very much. I'm Noriyuki Matsunaga from the University of Tokyo. And first, I'd like to say congratulations to the Prime team and the SAAO on the recent developments. I was a frequent visitor to SAAO for observation with IRSF 10 years ago. So it remembers times. Yeah, IRSF I used, but not so much now to South Africa. So I was very much impressed by the recent developments of SAO introduced earlier by Rosalind. So I hope I can come back to South Africa in the near future. Anyway, today I'm going to talk about Mira variable stars. The Prime telescope will play a crucial role in searching for Miras in the galactic bulge. Now, good. So I will conduct my presentation in the following order. First, I'm going to introduce Miras, the pulsating stars, and this kind of pulsating stars can trace intermediate age and old stellar populations. There are many Miras in the bulge, possibly about 1 million, but the previous surveys were very incomplete. So I will explain why we need a new survey. The key message of this talk is the Prime can fill the gap of previous surveys and provide complete sample of Miras in the inner bulge, although it is limited by interstellar extinction. In addition, the sound spectrograph introduced by Tamura-san will be very useful for classification and characterization of Miras. So let's start with the introduction. Miras are pulsating stars with long period and large amplitude. They are asymptotic giant branch stars with low effective temperatures and high luminosity, evolved from low to intermediate mass stars. Their ages range from 100 megayear to 10 gigayear, representing stellar populations over a wide range of age. Okay, some useful relations exist for Miras. Period luminosity relation, an example presented on the left-hand side, taken from Ita-san's work using IRSF data. The longer period Miras are brighter. And this relation is useful for distance determination. Then period age relation on the right-hand side. Longer period Miras are younger. So as soon as we determine periods from Miras, from observations, we can estimate their distances and ages, which makes them a very useful tracer of stellar populations. And Miras can trace the giga-year scale evolution of the galactic bulge. By observing Miras, we can study, for example, age distribution of bulge stars. And we can address when did the galactic bar form? Does the galactic bulge contain intermediate age stars a few giga-year, which is still controversial? We should keep in mind some technical issues, such as the metallicity dependency of period age relation has not been fully characterized. Okay, another important characteristics of Miras, or AGB stars in general, is their surface chemistry. Carbon is enhanced due to nucleosynthesis in each star, and AGB stars can dredge it up to the surface. If the surface carbon exceeds oxygen, they are found to be carbon-rich stars. Whether such carbon stars appear or not depends on the age and the metallicity distribution of stellar populations. Such process is important because the mass loss of AGB stars contribute a significant fraction of heavy elements, especially dust grains, to interstellar media. and the chemistry of released materials depend on how AGB stars end their life. I'd like to remark a legacy of South African astronomy. On this picture, you see 3 great astronomers, and I couldn't find a good photo with young grass. Sorry, but they contributed a lot to Miras and other topics. For example, IRSF was used for surveys of Miras in nearby galaxies in collaboration of the South African and Japanese team. And concerning the bulge, we used a spectrograph, Sputnik, at the 74-inch telescope in Sutherland to discover carbon-rich Miras in the bulge, which are very rare. Their origin is not well understood, and they may belong to a rare stellar populations in the bulge, or maybe evolved from binary interaction. Recently, Jason Sanders in UK and I published a paper based on Gaia spectra supporting the binary evolution scenario. Okay, so now let's move on to the main part of this presentation. Why do we need a new survey and what the prime can do? When we want to catalog objects in the inner galaxy or the bulge, one of the main problems is the interstellar extinction. I suppose you already know the interstellar extinction is a limiting factor in observing inner galaxy, and the galactic disk, it is strong and patchy. The extinction is smaller in the infrared compared to the optical, but still significant in low galactic regions. What you see here is the distribution of previously identified Miras towards the galactic center. The small gray dots shows the Miras from the OGRU survey in the optical. Red dots from the IRSF survey we reported in 2009, and blue dots from the BBB survey conducted with a 4-meter Vista telescope in Chile. You can see the gap. The OGRU optical survey cannot detect Miras in the low galactic latitude. The near-infrared surveys can detect low-latitude Miras, but the surveys have been very incomplete. Based on BBB data, Albarracin and colleagues reported a larger search recently. However, in any case, the saturation limit of 4-meter telescope is too severe. A large fraction of Miras in the bulge are too bright in the K-band. 2 other plots here show the same gap of the previous surveys, but in different planes. The brightness against log period on the left and against the galactic latitude on the right. For the brightness here, I converted 2 mass J and H band magnitude to HW band, a broad band around 1.4 micron designed for Japanese near-infrared astrometry satellite, JASMINE, which is, by the way, planned for the launch in 2031. We would see such a gap in any infrared band. So we need the new survey. Now, the prime can be a game changer. As we have heard already, the prime is 1.8 meter telescope in Sutherland and covers a wide field. For searching for Miras in the bulge, it is very important that it will take images in multiple bands for several years. The periods of Miras are longer than 100 days, typically 1 to 2 years. So having the year scale time coverage is crucial. Moreover, the data in multiple bands will allow us to detect Miras over a wide range of foreground extinction. The plot here shows how the bulge Miras at 8.5 kiloparsec becomes fainter with increasing foreground extinction. The extinction depends on wavelengths, stronger at shorter wavelengths. So the magnitude in I or Y bands, they become fainter more quickly than those in longer wavelengths, J, H, or K. The extinction towards the bulge show large variation from one line of sight to another, so some Miras are heavily reddened, while others are not so much. This complicates the search for Miras. But with the prime, with multiple bands, every Miras in the bulge would be within the detectable range of magnitude in 1 or 2 bands. J or H would be particularly useful. So the prime's microlensing survey would provide the most complete sample of Miras in the bulge. Unfortunately, I have no significant result to show yet, but some example images I checked clearly show Miras with different brightness are well within the detectable range. Miras are relatively easy targets as long as they are properly detected. No other kind of variable stars show long period and large amplitude variations like Miras. No doubt the prime will discover a lot of new Miras in the galactic bulge. So, in summary, Miras are bright and useful tracers of stellar populations with a wide range of age. The microlensing survey of prime can give a complete catalog of Miras in the inner bulge within its survey area. Additionally, they will be good targets for the sand spectrograph. For example, it will allow us to discover and characterize rare carbon-rich stars in the bulge. Okay, this is the end of my presentation. Thank you very much for your attention. Yes, I'd like to take questions if you can.
Would you like to mention, Noriyuki, that the Roman space mission will also be doing a galactic plane survey, which I think will be highly complementary to the prime survey. It will not do the time domain and it will go much fainter, but it will do similar aspects.
Yeah, that's true. The Roman can make also useful surveys only in the shorter wavelengths. So it will depend,
exactly.
the plan of the design of observations in shorter wavelengths if they make not so frequent, but repeating observations over years, they will also find the good samples. The prime have already studied observations. That's the advantage, and Miras are bright. So the prime will be fast.
Yes, of course. Many of them will be too bright for Roman, but Roman, some of them may provide things like proper motions.
Yeah, that will be exciting. Yes.